All right, so now we have two fractions. We are dividing the two fractions. And again, we are going to have to do what? What is the first step for dividing fractions?
Write down the second reciprocal.
Okay, we take the reciprocal of the second term.
Yeah.
So we have 8 minus 4a over 6. What do we do with the division?
You make it multiplication.
Multiplication. We still have 4 over 6 minus 3a. So nothing's different so far compared to normal dividing fractions. All right. So our next step here is going to be, we are going to have to cross-reduce, but we can't really fully cross-reduce yet. There's something else we have to do. Now, I'll remind you that we have binomials in the denominator of the first term and the numerator of the second term. What do you typically have to look for when you are given bi or trinomials or any polynomial? What are you going to be asked to do?
The greatest common number.
We're going to have to look for a greatest common monomial. We're going to have, that's right, the F word. We're going to have to factor. All right. All right, so what goes into 6 minus 3a? What goes into 6 minus 3a? Nick? 3 goes into both of them. All right, so the 3 gets factored out. 6 divided by 3 is? 3a divided by 3. And we still have our numerator of 4. We're multiplying it. What is the factored form for our numerator here? What is the factored form for our numerator here? Michael?
4, like the whole thing. And then parentheses 2 minus 8.
And then again, we'll have the 6 in the denominator. All right, so now we can reduce. Now we're ready to reduce. And this is why we have to reduce before we multiply, or else we'll end up with a mess. Okay, what parts can be reduced? What shares of factors? Ashby?
Well, the 4 and the 6.
Okay, the 4 and the 6, what factor do they share?
2.
So 4 divided by 2 is 2. 6 divided by 2 is 3. All right. What else shares a factor? What else shares a factor? Sarah?
2a and 2a. You can just cross them out. They're the same thing.
2 minus a and 2 minus a.
Sorry,
Yes.
sorry, that's what I meant.
They're the same. They can be crossed out. All right. So at this point, what do we do now?
Multiply.
Multiply across. So 4 times 2 is?
8.
3 times 3 is?
9.
And there you go.
Do it.
Now we should talk about restrictions really quickly. Obviously, if we're looking at this one, a cannot be equal to 2 because that would give us a 0 in the denominator, but there you have it. That's what all right, so question B is a little bit more complicated. Instead of giving us binomials, we have some trinomials, and it looks like all 4 of those terms can be factored. So we're going to have to factor both numerators and both denominators before we're able to reduce. But this is nothing terribly scary. It starts the same way as all the other problems do. What's the first thing we're going to do? Michael W.?
First thing we're going to do.
It's always, but when you're caught off guard, it's always appropriate to restate the question, which is good. We multiply by the reciprocal. All right, we have a nice little Michael group going on here. So x squared minus 225 over x squared minus 4x minus 5. Does this fraction remain the same?
Yes.
It does. Okay. So we have x squared plus x minus 20 all over 5x plus 25. Let's deal with the easy ones first, shall we? Let's deal with the binomials. How are we going to factor this term here? Margot?
Can you do a greatest common monomial of 5?
Greatest common monomial of 5. All right, so we're going to factor out the greatest common monomial. Margot's pointed out that it's 5. So what goes inside the binomial here? So, x plus 5. Now this is going to be really helpful because I am willing to bet my entire paycheck for the year, which isn't much, that there's going to be an x plus 5 over here, because then you can reduce, okay?
I am gonna.
That's why these end up being a little bit easier to factor, because you always have a clue what you're looking for. All right, so x squared minus 25. How do I factor out this? Beth? They're both squares. We have a difference, therefore it is a? Oh. All right, it is a difference of squares. How do I factor a difference of squares?
You just do the two parentheses, 1 plus 1 minus.
Okay.
And then put x plus 5 and x minus 5.
All right. Oh my goodness! Look, I get to keep my salary. Woohoo.
OMG.
All right. So then let's take a look at this trinomial. We're going to have to factor it. Is there a greatest common monomial that goes into those three terms? No.
No.
Is this a square binomial? No, because negative 20 is not a square. So this is going to be a pair of binomial factors. So I can just go ahead and put my two sets of parentheses. All right. Well, what do I know about the signs in this problem? We should already have a clue as to what signs go inside the binomial. There'll be an addition and subtraction. Because why? Because that's negative. Okay. All right. So what factors of 20 add up to positive 1? What is a factor pair of 20 that together, or negative 20, that together add up to positive 1?
Positive 5
Positive 5 and negative 4. And then we just have our x and x. Now, there's a good bet that one of these two binomials is going to end up in the denominator here. It's a really good bet.
Understandable.
Okay. All right. So, again, looking at this problem here, is there a greatest common monomial? No. Is this a special case trinomial? No. All right, so we're looking for a factor pair of negative 5 that add together to get negative 4. And what would it be, Sam?
X minus 5 and x plus 1.
All right, and so now we have gotten to the really exciting moment where we are going to be able to cross-reduce. So what factors can I reduce before I am stuck multiplying this thing together? All right. Don't want to call on the same people every time.
Wait, what did you mean by like like you can't multiply them?
You could multiply them together, but it's a lot easier if you reduce first and then multiply, because if you multiply everything together first, it's just, I mean, you may miss the factors.
Oh, okay.
So that's why you want to reduce first. It just makes life easier. Kate, what goes into, what factors do we share?
The quantity of x plus 5.
X plus 5 and x plus 5. What else do we share?
Could it be?
It can be in the same, yeah.
Wait, can you reduce? You can't reduce up and down, right?
Oh, yeah, you can.
You
Yeah.
can't?
Oh,
you
yeah.
can?
Yeah.
No,
Then those two.
So
Wait,
would that be 1 or would that be 0 at the top?
Well, if you divide x minus 5 by x minus 5,
It would be 1.
it's going to be a 1.
Okay.
All right. is there anything else that we can reduce in this problem? Is there anything else that we can reduce in this problem?
Well,
Well,
I have a question.
Your question?
So, you could not reduce the x plus 5 to with the other pair of x plus 5s because there's nothing else to cross out with it.
Right, so you're kind of stuck with that x plus 5.
Or
Okay, so now that we have reduced everything that we can reduce, what do we do with the fraction?
multiply it?
Multiply the numerators, multiply the denominators. So 1 times x plus 5, x minus 4,
It's just x plus 5.
okay, it just remains the same. X plus 5, x minus 4. 5 times x minus, or x plus 1 is just 5 times x plus 1. And it is typical to show your answer in factored form like this. So you do not need to multiply it out. You do not need to expand it. That is the end result. Yes, ma'am.
So, say, for the second set in the numerator, the quantity of x minus